We already learned such kind of graph in our O levels. So how we can calculate the gradient of the graph? If I consider 2 points like x1 and y1 and x2 and y2, so you know gradient is what? Y2 minus y1 over x2 minus x1. We already know those things, right? We already know those things, right? And if I give two graphs, graph number 1 and graph number 2, and if I mention here the gradient is m1 and the gradient is m2, out of two graphs, which one has the higher gradient? High gradient means the higher slope. Higher slope. So you can imagine the graph number 2, the gradient m2 is greater than m1. Now you can get idea. If I give two graphs, then you will be able to understand out of two graphs which one has the highest gradient. Which one has the highest gradient, right? And the next case, I am going to draw four graphs, right? Now the next case, here gradient is m3, m4. Again, I have drawn two graphs. So whatever the place we have drawn it, you can see m4 has a higher gradient than m3. Now you can get idea. If I give two graphs, you can get idea out of two which graph has the highest gradient, right? And I am going to draw the further. Yeah, I am going to divide as m1 the gradient, m2. Now I have drawn four graphs. This is m1. M1, this is the x-axis of the graph, right? Out of four graphs, now we will be able to arrange these four graphs according to ascending order of their gradient. So out of m1 and m3, we can get idea. M1 has the lesser gradient. So the next nearest gradient is right belong to m3. The next one is out of 2 and 4 will be m2, and the highest gradient belong to m4. Now we can get idea. Out of four different graphs, the m4 means the gradient belong to the fourth graph. The fourth graph, or this one, has the higher slope as well as while the first graph has the lower gradient. Now you can get idea. Out of four graphs, which one has the highest gradient, lower gradient, and the middle gradient in between that. Now I am going to talk about the curve graph. Curve graph. Out of the four curve graph, and I am going to draw a straight line graph. You can see the slope of the straight line graph is remaining constant. The slope or the gradient is remaining constant. If I draw a line and if I'm going to measure the angle, you can see the angle is equal. These two lines are parallel to the x-axis. So gradient is uniform. But if I consider the initial graph, you can see the gradient is not uniform. So then first I am going to draw a tangent to this point. The angle is θ1, and I am going to draw next tangent to the given point, θ2. you can see theta 2 is theta 1. Therefore, in this graph, gradient, so I'm going to represent the gradient by m. Gradient is increasing. In this graph, gradient is increased towards the positive direction. You know, this direction is positive. So we can say the gradient is increasing. Gradient is increasing, right? Gradient is increasing. And I'm going to draw the next graph. This is the next graph. This is the next graph. So I'm going to draw a tangent to this point. The angle is theta 1. So I'm going to draw the next tangent to somewhere in here, theta 2. You can say theta 2 is less than theta 1. Theta 2 is less than theta 1. So here, gradient is decreasing. Gradient is decreasing in here, right? Gradient is decreasing, right? So now I am going to discuss two graphs. So I am going to draw any other graph now. This is the next graph. No matter, now you know the procedure. Consider this is your point number 1. Draw the tangent. The next one you can see theta 1, theta 2. You can see theta 2 is greater than the theta 1. So gradient is increasing. Gradient is increasing. The next one. The next one. This is the graph. Now you know the procedure. So we have to draw two tangents. So you can see m is decreasing. M is decreasing. So likewise, all of the four graphs I have drawn. Now you can see my graph. Whatever the graph, right? Whatever the graph. Now you know how to find out its the gradient. Now you can know how to find out its the gradient, right? We have started velocity time graph the last week. Velocity time graph last week. So you can see this line, straight line. This person is sitting on here. The point I am going to define as O, right? Relevant to this point, I am going to define this direction is positive and this direction is negative, right? So first I am going to explain the person is at the rest. Person is at the rest means the position of this person will not change along with the time. And initially I am going to mention the person is sitting on that place. Zero displacement. So along with the time, the displacement will not be changed. This is the graph. This is the time, second, this is the displacement, meter. You know, the displacement line is just drawn on the x-axis. Why? Because displacement will not change. So next case, I am going to draw in here. When t equals 0, person is at standing on this point. It means the person already in his positive direction. When t equals 0, when t equals 0, the person already make a displacement. The case number 1, person at its initial position, therefore no displacement. But then now, when t equals 0, person already made the displacement. The displacement is defined as x. And along with the time, the displacement will not change. But when t equals 0, person already made the displacement. Right? The displacement value is remaining constant. The value will not change along with time. The next case, person is sitting in here. So I'm going to define the point is C. Right? When t equals 0, person already made the displacement towards its negative direction. One Q may affect the positive, may affect the negative. So then this should be the graph. This is negative x. This is negative x. Those things we have discussed in the last week. Those things we have discussed in the last week. The next case, those are the persons standing positions. I'm going to define as A, make a O. Person is sitting in here, or sitting in here, or sitting in here. A, B, and C. Now, the person want to move towards the positive direction. V velocity, uniform velocity. Person move towards the positive direction with uniform velocity. So I am going to draw one graph now. One graph. First, I am going to draw the graph belong to the first case. Person moving with uniform velocity. But I am going to draw a velocity time graph. Sorry, displacement time graph. So this should be the graph. Belong to case number A. Right? In the displacement time graph, we can find out the starting position of this person. There is only the displacement time graph. We can find out the initial starting position of the person by simply observing the position of the person when t equals 0. When t equals 0, displacement is 0. If I am going to draw a graph belong to the case number B, person is sitting in the position X. Graph of B. Both lines are parallel to each other. Why? Because the velocity is equal. Case number 3, negative X. Case number 3. Right? This is the graph. And if this person want to move, towards the negative direction, V velocity towards the negative direction. So in this graph, this is the positive direction, this is the negative direction. First case belong to A. Person moving towards the negative direction with uniform velocity. A. Now I am going to draw for the case number B. Initial displacement is positive x, but moving towards the negative direction. B. Person already made the negative displacement. Negative x, but moving towards the negative direction. No need to represent arrows, but I want to show you all three lines are parallel to each other. Next case, person move towards positive direction. Person move towards the positive direction with acceleration. Acceleration. Now I hope to put all of the graph in same axis. The case number 1. Person move towards the positive direction with acceleration. Now you can see. මෙයා යන්නේ positive පැත්තට acceleration නිසා තමයි මේක මේ පැත්තට ගියේ. මේ පැත්තට acceleration එකෙන් ගියා නම් graph එක යන්නේ මේ පැත්තට. හරි. Now you know this is A නම් මේක B වෙන්න ඕනි. Positive x. It should be negative x. Now this person want to move towards a negative direction. Or he want to move negative direction with same acceleration. So graph now move towards the downward, right? Now you know how to represent the acceleration. Now you know how to represent its acceleration. Gradient is increasing. Make A. This is B. C. Now I am going to explain. This person move towards positive direction with deceleration. And decelerate again. But understand, when t equals 0, this person is at the rest. So rest එක හිටපු කෙනාට decelerate එකෙන් යන්න බෑ. නේ? So එහෙනම් what happened? When t equals 0, person should start to move with higher velocity. He already have initial starting velocity. Along with the time, speed will be reduced. Along with the time, speed will be reduced. එන පුතා මෙන්න graph. You know, gradient is reducing. A, when I make a B, C. Moving towards positive direction with deceleration. Gradient is reducing. Right? Now, this person want to move towards a negative direction with deceleration. So the graph would be right. The last time I have done a mistake. Again, once it moving with the acceleration, gradient should be this one, right? It is moving deceleration. Moving deceleration. Now I am going to explain velocity time graph. Now I am going to explain velocity time graph. Now I am going to explain velocity time graph. So in the velocity time graph, v ms minus 1 t seconds. Now I am going to remind our initial cases. This is A, point O. Person is at here. B, C. Person is what? The first I am going to explain. You have to draw those things. I am going to talk about velocity time graph. In the VT graph, we have to rename the both axes and we have to write down the relevant units. Velocity ms minus 1 t seconds. Now assume. Now we want to plot VT graph, but in the first case, person sitting and rest. Write down subtopic. Person sitting on rest. Person sitting on rest. එතකොට මෙයා මේ ස්ථාන තුනේම rest taking the pullover. Right? The heading should be person checking on rest. By me, I made 10 to name rest taking the pullover. I have told you in the ST graph. I'm going to draw a ST graph. This is the case A, case B, case C. This is the displacement. This is the time axis. I have told you in the ST graph for displacement time graph, we can find out the person's initial starting position. Make a balloon pain. T equals 0 the displacement tag කරලා නැහැ මෙතන. මෙයා නම් positive පැත්ත displacement tag කරලා ඉන්නවා මෙතන. මෙයා displacement tag negative පැත්ත. The displacement time graph we can find out the person's initial starting position. But VT graph we can't find out. In the VT graph we can find out the person's starting position. So whatever their initial starting positions, we have to put only one graph. මෙයා T equals 0 වලදී velocity equals 0, v equals 0. Why? Because person is sitting. And this should be the line. This should be line because velocity is 0 for all a comma b comma c instances. The next case, person moving towards positive direction with v uniform velocity. Person moving with v uniform velocity. මනුස්සයා ඉන්නේ මෙතන positive පැත්තට යන uniform velocity එකේ. First I am going to discuss again the velocity time graph. මතක තියාගන්න මෙයාගේ A ගේ graph එක මෙහෙම ආවේ, B ගේ graph එක මෙහෙම ආවේ, C ගේ graph එක මෙහෙම ආවේ. Because this is displacement time graph. This is velocity time graph. Now person moving towards the positive direction with v uniform velocity. මෙන්න v for a comma b comma c. තුරට මෙන්න එකම graph එක. Uniform velocity එකේ. Next case, person moving towards the negative direction. Uniform velocity. Graph now should plot with මේක නම් ඉන්නේ මෙන්න මේ පැත්තට. Next one, person moving towards the positive direction with acceleration. Acceleration එකෙන් යන්නේ. මෙන්න බලන්න අපේ මුලින්ම ST graph එක කොහොමද ආවේ? මෙන්න මේ. මෙන්න මේ acceleration එකෙන් මෙන්න මේ පැත්තට. මෙන්න acceleration එක. One graph for all three instances, but three different graph for three different instances. Person moving towards the positive direction with uniform acceleration. The next one, person moving towards the negative direction with acceleration. towards the negative direction. मैंने ग्राफ है मैंने डिस्प्लेसमेंट टाइम ग्राफ मैंने वेलोसिटी टाइम ग्राफ